Hi everyone. In this session, we will look into the Apache Kafka. The Apache Kafka is a very important topic, and most of the time, this would be asked in the system design interviews. And also, if you are trying to build your career into those companies where distributed system plays a heavy role, then I would suggest you to look into this video. And the second point that I wanted to tell here is I am using the open source software of Kafka. I am not using any of my company resource here or any of the company's code. This is like anyone can use this, anyone can install it onto the system and start playing with it. So this is freely available into the operating systems like Ubuntu, CentOS, or Windows, or also you can install it onto the Mac OS. That's point number two. The point number three is like why am I trying to do this video is like I am trying to create this video. I need to spend huge amount of time, and by spending the huge amount of time I'm learning new concepts. So the only intention here is I'm gaining by sharing. That's one thing. And I'm not trying to make any money, or I'm not trying to show off here. So let's not worry about others and then jump into the Apache Kafka topic. In the Apache Kafka, we keep on listening to the terms called as producer. A producer is nothing but a one who produces the data. And this data would be consumed by the users, and we call them as consumers. So you keep on listening to this word producer and then the consumer. And also in the Kafka world, you keep on listening to the word called as brokers. The brokers are nothing but a one who stores the data what the producer has produced for. All the data which has been produced by by the producer would be stored in the broker. So we will form a cluster of systems here. So the brokers can be installed on a single laptop, or it can be installed on the multiple machine. Eventually, the companies like YouTube, Netflix, or LinkedIn, who might use this Apache Kafka, they will install a brokers on huge set number of systems. So in this diagram, I have used five brokers. That means I have used five systems, and each system I am naming it as broker one. I will be installing it on system A. Broker two, I will be installing it on system B. Broker three, I will be installing it on system C, and D broker 4, and E broker 5. So the producer produces the data, and the data would be stored inside this broker. So it's like whatever the data you have consumed produced, that would be stored in the hard disk of this broker, and the consumer will consume the data from or read the data from the broker. So that's point number one. Like you now understood what is producer, how the producer produces the data, and then that would be consumed by the consumer. The next important topic here is you keep on hearing to this word called as zookeeper. A zookeeper is nothing but a one who maintains the list of the active broker. Like if there are five brokers, the zookeeper knows that there are five active brokers. So there would be an heartbeat kind of information that would be moving between the zookeeper and then the broker. So the zookeeper detects, okay, there are five brokers who are active. So that's one thing. And then the second important thing what zookeeper does is he elects the controller. I will come to that controller topic later on. And the third important topic is he manages configuration of the partitions and the topic. So he was is the one who manages the configuration of topic and then the partition. We will look into it further. Now, if you look into this diagram, you might tell, hey, Rajiv, this is a very far view of Apache Kafka. Can we go a little bit deeper? Now, let's try to go one step further and see how the Apache Kafka works. I have a producer. The producer produces the data. We call that as a topic at this point of time, and that the topic would be divided into the partitions, like the partition one, partition two, partition three, and partition four. The partition always starts with partition zero, then partition one, partition two, and partition three. Any data that the producer produces, it can go to the partition zero, partition one, partition two, and then the partition three. Now, once the producer produces the data and goes to the partition, then the topic would be placed into a broker. So if you see here, the broker 1, broker 2, broker 3, broker 4, The partition P0 data would be assigned to the broker 1. The partition P1 data would be assigned to broker 2. The partition P2 data would be assigned to broker 3. And then the partition P3 data would be assigned to broker 4. Now you might ask me the question, Rajiv, why are we doing this partition? Why can't we have a single set of the whole thing and then place it into one system? Now see, there is two reasons. One, the right operation. So it takes like if you put heavily on, like if you create one single set and place it onto one system, and if system goes down, that is one drawback. And then the second thing is you will be dividing the data. Writing the whole data will take more amount of time, so dividing the data into multiple partition is is necessary, and then it's a good way. So if one system goes down, also there would be other brokers who would be serving, rather than depending on one complete system. So that's one thing. Now the consumer consumes the data. Now you might ask me, Rajiv, in the previous diagram you did not add this rectangular table. Why did you add this thing? So this is nothing but a consumer group. So the intention of creating the consumer group here is consumer 1 and consumer 2 belongs to one consumer group. Consumer 3 and consumer 4 belongs to one consumer group. So if any data that has been written, for example, the P0 data will be consumed by consumer 1 and the P2 data will be consumed the the consumer one. Now you can't have P0 data consumed by the consumer 2. So the consumer on the particular group cannot consume the data from the same partition. So what I am trying to say here is you can't have a data consumed by this consumer because the P0 data is been already consumed by the consumer one. So that is what I was trying to say to you guys. Now let's go one step further. So the P1 and P3 data is consumed by consumer 2, and then the P0 and P3 data is consumed by consumer 3, and then the consumer 4 consumes the P2 data. Now if you see that, so there is no P2 data can't be consumed by consumer 3 because consumer 4 is consuming the P2 data. Now that's point. Now let's go to the next point. The next point here is zookeeper. Rajiv, in the previous diagram, you added one zookeeper. Why did you add four zookeepers now? The one topic what I read is if if there is only one zookeeper and if that system goes down, then the whole cluster is gone down, right? So instead of that, what we try to do here is we will have four zookeepers: zookeeper 1, zookeeper 2, zookeeper 3, and zookeeper 4. You can have n minus 1 is the is the one what they say, like quorum kind of thing. So basically what happens here is I have created four zookeepers. So if one zookeeper goes down, also the cluster will never go down because you have three zookeepers that are still active. And if this zookeeper goes down, like if the first zookeeper goes down and then the second zookeeper goes down, then the whole cluster comes down. So what I am trying to say is that we are trying to maintain the system availability. We are not depending installing zookeeper on only one system. We will install zookeeper on the multiple system. That is one more topic which I read. And the next important topic is, Rajiv, can this zookeeper be installed on one single system or in multiple system? I have installed the zookeeper on four different systems: system A, system B, system C, and system D. So basically, the zookeeper runs on the particular port. I think it is 2181. So you can run zookeeper on the four machines, or for the testing purpose, you can have only one machine and then install the zookeeper on that particular machine also. So that is one thing. Now let's go one step further and try to understand the other topic. Now, if you see here, uh, Rajiv, you said P0, P1, you said P2, and P3. So what happens if this broker goes down? If this broker goes down, then any data which is coming to this partition, 0, cannot be consumed because the consumer will one will never get the data, right? So to order to do that, we have something called as replication factor. In this, what we do is we will try to replicate the P0 data into multiple brokers. If you see here P0, I have divided that here also I have made the replication of P0, and the replication of P0 would be kept on the broker 5. So I have the replication of P0 on broker 4, replication of P0 on broker 5. Similarly, I have the replication of P1 partition on broker 5 and on the broker 3. And similarly, the replication of P2 is kept on the broker 2, and similarly, the replication of P3 is kept on the broker 1. So you keep on replicating that partition across the different brokers. So that is one more thing which everyone needs to understand when you are trying to run the Kafka. Now there is one more important concept called as leaders. So basically what happens is like there would be a leader selection. In this case, the P0 has become a leader. The broker one has become a leader for the P0 partition, and then the broker 2 has become a leader for the partition P1, and the broker for the P2 broker 3 has become a leader, and then the for the P4 this guy has become a leader. So what is the concept of this leader is, like, if a producer produces the data would be would be kept in this P0 partition, but it would be slowly replicated onto broker 4 and broker 5. But the consumer will consume the data only from the leader. So the leader is the one who reads the data, and then the leader is the one who which will be consumed by the consumer. But if this leader goes down, then the election will like one more broker 4 will become the leader for the P0 partition. So by this we are having the replication factor. So you can replicate and you can select the partition as a leader. So that is one more topic which I wanted to tell to you guys. The next important thing that I read was, uh, out of this, one of the broker serves as a controller. That means in this case, I am making broker 5 as a controller who is responsible for managing the state of the partition and then the replicas. So, so he is the one who is responsible. He's the one who act like a controller, and he is the one who is responsible for managing the state of the partition and then the replicas. It is not done by the zookeeper, it is by this controller. So the zookeeper is the one who elects this controller. The controller is the one who is responsible for managing the state of the partition and then the replicas. So that's one more topic which I read. Now, the next important topic that I wanted to explain to you guys is, Rajiv, can we have one cluster which is there in one producer and one more cluster where there are set of producers and consumers? So this is in US, this is in India. Can a producer produces the data and can be consumed by the consumer who is in India? Usually, yes, that is also possible. I read that like there can be a cluster to cluster communication also, and I have not tried this, but I'm just sharing this information that it can be done. Like the producer can be in US and then the consumer can be in India office and then they can consume the data. Now, Rajiv, I want some more information on how this data is actually written. How is the data written by the producer and how is the data consumed by the consumer? So, if you take a data and then you have a partition which has been created, and then the producer produces the data. So the producer produces the data would be kept in the form of offset. So 1, offset 2. So anything that he writes, any data that has been written by the producer, the next data will go and would be placed in this offset number 3. So the next data which will be read will be placed in offset number 4. So that is how the producer produces the data. Okay. Now you might ask me the question, Rajiv, how does the consumer consumes the data? So the consumer, what he does is the consumer would be present here. Consumer, so he starts reading the data from the beginning. So he starts reading the data from here. The next data would be read from here, and then the next data would be read from here, and then it starts waiting for the new data. So that is how the producer produces the data, and that is how the consumer reads the data from the partition. Seeing this, I will end my presentation.